All right, these are the notes for section 8.1. Now this chapter, chapter 8, is all about sequences and series. Now a sequence is just a list of numbers, that's all. You can see on here, a sequence is just an ordered list of numbers. Now the ones we're talking about will always have a pattern that we're looking for. Like here's a couple of examples. Here's a sequence like that. Here's another one. Just a list of numbers with commas between them. Now later we will also talk about series. Now a series is just like a sequence, except now a series is a sum. So when you add the terms together, and that's what each of these things in the sequence is called a term, when you add those together you get, and you find the sum, that's a series. So a sequence is just a list of numbers. A series is if you add up some of the terms in that sequence of numbers. Now some things to get used to seeing. First is a sub n. A sub n represents the nth term. If I talk about a term formula, that'd be another way to think about a sub n. It's what you use if you want to find any term. You just plug in numbers for n. So like a sub 1 is the first term. So on your examples, like these first examples here where it says, write the terms of the sequence. So let's write the first 6 terms. Well, all we're going to do is plug in numbers for n. So the first term is n equals 1. We plug in 1 for n. 2 times 1 is 2, plus 5 is 7. Then we try n equal 2. That'd be our second term. So if we plug in 2, 2 times 2 is 4, plus 5 is 9. N equals 3. 2 times 3 is 6, plus 5, 11. N equals 4. 2 times 4 is 8, plus 5 is 13. N is 5. 2 times 5 is 10, plus 5 is 15. And n is 6. 2 times 6 is 12, plus 5 is 17. So that's how you use the term formula, a sub n, to find the term. You just plug the n numbers in. Same way with number 2. Now this one's a little bit trickier because the n is up in an exponent, but it's the same idea. We're going to plug in n equals 1. So if we plug in 1, I'll go ahead and write that out. That's going to be negative 3, and the exponent will be 1 minus 1. Well, that's 0. Negative 3 to the 0 is 1. Then we plug in n equals 2. That'll be negative 3 to the 2 minus 1. So that'll be negative 3 to the first power, which is negative 3. Then n equals 3. That'll be negative 3 to the 3 minus 1. Again, you see all I'm doing is plugging the n number in for n. That'll be squared. Negative 3 squared is a positive 9. Then 4. That'll be negative 3 to the 4 minus 1, which is cubed. Negative 3 cubed is a negative 27. Then 5. That'll be negative 3 to the 5 minus 1. Well, that'd be negative 5 to the 4th. That'd be like multiplying this one by negative 3, so it's a positive 81. And then 6 would be negative 3 to the 6 minus 1. Negative 3 to the 5th power is a negative 243. So that's just how you plug them into your term. So once you have your term formula, you can find any term just by plugging the number of the term, like first, second, third, fourth, fifth, in for n. Also a note here, notice here the negative 3 was in parentheses. If you ever had one that looked like this instead, where the negative was not in parentheses with the 3, that would get the same numbers, except here they would all be negative. So they wouldn't alternate like they did here. So that's a difference, because here the negative is included with the 3, so when you square it, you square the negative also. Here it's out front, so it just means all these answers are going to be negative. Okay, so that's substituting in. Now, the next thing is, I think this is the hardest thing, quite frankly, in this section. That is coming up with the term formula. Like here, they're going the opposite direction. So here, notice they gave you the sequence. Negative 1, negative 8, negative 27, negative 64, and we need to come up with the a sub n, the formula a sub n. The first thing I always do is number these. So 1, 2, 3, 4. and I look for some pattern here. Now, if you look for a pattern, like if you look at going across, do you add the same thing every time? No, because here they subtracted 7, they subtracted 19, so it's not the same. Did they multiply by the same? Well, they multiplied by 8, they multiplied by some fraction, so that's not the same. So if I write down the n numbers, I'm trying to tie these two things together. I don't see any way that works there. Then the next thing I try is n squared. So that would be 1, 2 squared is 4, 9, 16. And I look for a pattern there. I don't see anything there either. Although here is like 4 times 2 is 8, 9 times 3 is 27, 16 times 4. So it looks like we're getting close. Let's try n cubed. 1, 2 cubed is 8, 3 cubed is 9, 4 cubed is 64. Well, now you see these match except for the negative sign. So here our term formula, a sub n, would be n cubed, except they're all negative, so we'll put a negative out front. So to describe the pattern, each one of those is the number cubed. When it says describe the pattern, it says each term is n cubed. Then it asks for the next term. Well, if this is 4 cubed is 64, 5 cubed would be 125. So a sub 5 would be a negative 125 because it would be 5 cubed. Okay? Same thing with this one. Look at a pattern. Well, it looks like we went plus 2, plus 4, plus 6, etc. So we went plus 2 more each time. You could list that as your pattern. The next term then, let's see if I went plus 2, plus 4, plus 6. The next one would be plus 8. So the fifth term would be 20. And a sub 5 means the fifth term. Now for our term formula, let's number them again. So n equals 1, 2, 3, 4. I don't really see anything there. Let's try n squared. 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16. Well, look for a pattern there. Well, none really jumps out, but notice something. Look at these two numbers we put. What if I subtracted those? 1 minus 1 is 0. 4 minus 2 is 2. 9 minus 3 is 6. 16 minus 4 is 12. That looks like a pattern. Well, there we took n squared minus n, so let's let that be our term formula, n squared minus n. The next one's a fraction. Now, when you're given a fraction, it's good to look at the top and the bottom separately. So here, if you look at for a pattern, 2/5, 4/5, 6, it looks like they go up, so they add 2/5 each time. That'd be the pattern. So that means the fifth term, if we added 2/5, 8/5 plus 2/5 is 10/5, which is 2 would be the fifth term. Now for our term formula, let's number those. 1, 2, 3, 4. Well, now I see a pattern there. Notice if we take n and double it, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. So the top number looks like if you took n and doubled it. So my nth term, the top would be 2n. Now the bottoms are all 5s, so let's just say the bottoms are all 5s. There would be our term formula. Okay? The next thing are the sums now. Here we're getting into the series. When you write sums, a lot of times you use what's called sigma notation. Here, sigma notation looks like this. Oops. Looks like that. You see that? That's a Greek letter sigma. You may have seen it on a fraternity or sorority. Sigma means sum. Whenever you see sigma notation, that always means sum. In fact, sometimes you might see that on a calculator, and that's what it means. Sigma means sum. Now, in sigma notation, you have three things. So it represents a sum. The number on the bottom down here, I equals 1, that's the first number you substitute in for n. So whatever number's on the bottom, that's the first number substituted in for n. On the top, that number on the top, that's the last number you substitute in for n. So it's written out here. The number below the sigma represents the first number to substitute in for I or n, whatever letter you use. I don't know, they use I a lot of times in sigma notation. The number above the sigma represents the last number to substitute in for I or for n. Then the thing to the right of it, that's your term formula. That's your nth term. That's what you're going to substitute into. So like here, if we're looking at this one, we want to write this in sigma notation. Well, if I number the terms 1, 2, 3, etc., if you look for a pattern, well, 1 times 25, 2 times 25, 3 times 25. So if I were doing my sigma notation, my a sub n would be 25 times whatever n is. So that goes, that's a nice sigma. So that's what goes beside. So right beside here always goes a sub n, 25n. Now at the bottom you put what you start substituted in first. Well, here we put in a 1. So I equals 1 or n equals 1. Either one you could use. Now on the top, we don't know which term this is. We would have to figure that out. Well, if we kept going, we kept adding 25 each time, wouldn't 250 be 25 times 10? And we said our formula was 25 times n, so isn't n 10? So that's what you put on the top. So this tells us this is the sum of all the terms of this series, where you plug in 1 first and you keep plugging in until you plug in 10 and you add all those together. So that's summation notation, sigma notation. About this one with the fraction. Now if we look at this, again, we're going to do this in sigma. If I put in my numbers, n equals 1, 2, 3, 4. Remember a fraction, I said look at the top and bottom separately. Well, on the top, don't those all just match the n numbers? 1 to 1, 2 to 2, 3 to 3, 4 to 4. So let's put n on the top. So for a sub n, we're putting n on the top. Now aren't the bottoms always just one more than that n number? So on the bottom could be n plus 1. There's our term formula. Now for our numbers, well, our first n value was 1. So at the bottom we put n equals 1, or again, you could use I equals 1 if you wanted. Now notice here that dot, dot, dot means it goes to infinity. So this one goes forever. So our last number, there isn't one. We're going to put infinity up here on the top. So that would be sigma notation for that one. Okay? So that's how you put it in sigma notation. Find a sub n, just like we did with a sequence, and put that beside it. On the bottom, you put what number to plug in first for n or for I. And on the top, you put it whatever number you plug in last. If it's infinite like this and ends in dot, 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 you put an infinity up here. Here, if you figure out which term you end up, like here, that was the 10th term, we put a 10 on the top. Okay. The next set is actually finding the sums. Here, we're just going to write them out. When you get one that's fairly short like this, you just want to write them out. So here's the sum from n equals 1 to 6. So that tells you to plug in 1 first and keep plugging in until you get to 6. So if n is 1, that'll be 2 times 1 is 2 minus 1 is 1. N is 2, that'll be 4 minus 1 is 3. N is 3, that'll be 6 minus 1 is 5. N is 4, that'll be 8 minus 1 is 7. N is 5, that'll be 2 times 5 is 10, minus 1 is 9. And n equals 6, that'll be 12 minus 1 is 11. Notice there was 6 was on top, 6 is here, so that tells us where to stop at right there. Now, to find the sum, we just add those together. Let's see, 11 and 9 is 20. 7 and 3 is 10, that's 30, plus 6 more, looks like 36. Same with this one. We're going from 4 to 8. Now notice here, we're not plugging in 1 first, we're plugging in 4 first. Remember, the bottom number tells you what to plug in first. So if we plug in 4, that'll be 3 plus 4 squared. 3 plus 16 is 19. Then we plug in 5. 5 squared is 25, plus 3 is 28. Then we plug in 6. 6 squared is 36, plus 3 is 39. Then we plug in 7. 7 squared is 49, plus 3 is 52. Then we plug in 8. 8 squared is 64, plus 3 is 67. Notice we got to 8, and that's the top number on here. So that's when we're done substituting. Now we just add those together. Let's see, 1, 2, 3, 4, 5, 6, 11, 17. That's 177, 179, 188, 196. Looks like 205. So our sum, that's what this represents, is 205. Now these next ones are some where we can use a formula, and they're just special cases. There's nothing you can figure out. They're just a special case. They're here in your notes. Like notice this one says I squared. Well, if you look in your notes, it says, see how this one here says I squared? If you have I squared, you take n times n plus 1 times 2n plus 1 over 6. So for this one, we're going to take n times n plus 1. Well, n is 1. Sorry, n is 7, excuse me. So the top number, n, is 7. Then it was times n plus 1. So 7 plus 1 is 8. And then it says 2n plus 1. So that'll be 2 times 7, 14, plus 1 is 15. All over 6. So we got all that from that formula. Again, that was n times n plus 1 times 2n. Covering it up. That's n times n plus 1 times 2n plus 1 all over 6. So 7 times 8 is 15. 15 times 50, or well, 6 goes into 15. You can simplify that. And if you work that out on your calculator, you should come up with 140. So we take 7 times 8 times 15 divided by 6, 140. The next one, notice the term formula is just a plain old 1. Again, if you look at these special ones, see this one here says the sum of 1, if it's just a plain 1, equals n. So here, n is 28, so this just equals 28. The last one is an I. Well, if you look over here, here's I is the second one. Notice I is n times n plus 1 all over 2. So here we're going to take n times n plus 1 all over 2. So for this, an n is 25 times 25 plus 1 is 26 all over 2. When you work that out on your calculator, it's 325. So 25 times 26 divided by 2, 325. All right, so that's it for 8.1.